Hi, it's Craig here. Today I want to talk about turbochargers. So what is a turbocharger? And I think you need to look at the big picture. So let's look over here at this engine and we can see a turbocharger. The exhaust is coming out of the exhaust manifold and going into part of the turbocharger, and then it's causing a reaction, which I think we can talk about on the bench. But that's the turbocharger mounted to the engine. You can see where it's going out. So I'm going to direct our attention down onto a cutaway of a turbocharger here, and we can see in this turbocharger that we have a cast iron housing on the exhaust side, and then on the turbine side it's made of aluminium. So the exhaust manifold exhausts into the turbocharger here, and that hot expanding gases is going to cause this wheel to start to turn. And when it turns, you can see that there's a shaft going through to the impeller. So this impeller is a centrifugal pump. So the faster this turns, the more air it starts to produce. Now, the air is coming from the filters, and it comes in here, and it's charged by this spinning wheel, and this actually creates pressure. Now, this pressure built up on this side is referred to as boost, and that boost is going to go into the engine cylinders. So let's go back to the turbine side. So the hot expanding gases of the engine are flowing through this turbocharger, and they're going, they're going this way, I think, and then pushing the wheel and spinning the wheel. Now that wheel can be spun at 100,000 RPM. So on the impeller side, a lot of airflow is being created. So now we have this turbine pushing this impeller, creating that flow. Now this air is hot and compressed, and the laws of compressing air says that it's going to heat up. So when it heats up, we're going to get less molecules of oxygen per volume of air. So what we do is we run that air through a cooler. It's just a radiator, and the air from the fan of the engine will blow across that and cool this air. So we have high pressure air going into the cylinders that's been cooled. So that is a huge advantage. This gives us 50% more power, and again ensures that there's enough air in the combustion chamber to have a complete charge, so it burns hot rapidly and reduces emissions. Also, the turbulence and the pressure going in there helps the air turbulence in the cylinder, which all diesel engines need, and mixes the fuel better. And this is an advantage. I guess a disadvantage would be the air must be cooled so that it'll get enough volume of oxygen in the cylinders. Now, something can go wrong with this as far as it can create too much boost, such as going up a hill with the engine at high RPM. So not shown here is a wastegate. And the wastegate will allow some of the exhaust to bypass the turbocharger, and that will reduce the speed and the boost. So what could go wrong? What could go wrong with this is not enough volume of air going into the impeller, so plugged air filters. A plugged air filter will limit the amount of air going in, and even so the engine is putting the same amount of fuel in and not enough air, we're going to see black smoke being produced. Also, rarely, but it can happen, is valves can be broken or damaged, and when that happens it will come through the turbocharger and it will hit these vanes and damage these vanes. Now as soon as those vanes are damaged, it'll be imbalanced, and you can see here what we got here is the bearings. There's some seals and there's the bearings. This area is flooded with engine oil from the engine. So the oil pump creates the flow and sends oil into here, and then it overflows and goes back into the engine through a return tank tube. So if that becomes plugged, that return tube, the oil can't get out of here, the oil will literally be pushed through these seals, and we'll start to see more black smoke, possibly blue smoke. And in a hot working engine, you could even see it as gray smoke. So the return line must be clear so the oil can return. The pressure side, there must be enough oil supplied to this, and this is one of the first places oil goes. Because of the speed of this turbocharger, if this isn't constantly lubricated and cooled, it will seize up, and this shaft will seize and the turbocharger will stop. When that happens, we'll see a lot of black smoke. So again, on the impeller side, if there is no air cleaner, we would get material coming through, possibly small bits of material. With this turning at 100,000 RPM, those would be little bullets being shot at this guy, and again, it could cause imbalance. One of the things we check for with a turbocharger is the vanes. We check the vanes to make sure they haven't been damaged, bent, or any missing. We also checked axial play, and this one looks pretty good. There's not too much axial play in there. This spins very fast, very tight tolerances. I think you can see right here that the tolerances are very fine on both sides. So we have to be very careful that there's no damage. There's a little bit of play in here, but it is a cutaway. So one of the things that we have to make sure when we're finished using the turbocharger, so we've gone up a large hill and we're pulling into Tim Hortons for coffee, this turbocharger needs to be cooled down. And what we do is we basically stop the engine, or as we're idling into the parking lot, for 3 to 5 minutes, half throttle. And that's going to allow oil flow into these bearings and then flow back into the engine, be cooled, and more oil flow so that this starts to cool off. These bearings actually go red hot. The shaft can go red hot. Remember that this engine is under heavy load, and the heat of the exhaust and the spinning shaft makes this area very hot, which is transferred through the whole turbocharger. So it needs its lubrication. Finally, 3 to 5 minutes at half RPM, 3 to 5 minutes at idle, and then the engine can be shut off and the turbocharger will be fine. Now here I've got another turbocharger that I can show you, and this one isn't a cutaway, and we can get a very good idea of it. So here we have the turbine, and you can tell because it's cast iron. And there is our wheel, our fins, and again, they look in good shape. I'm just checking them for play, and there isn't any play, so that's looking good. That's where our exhaust is going to go in. This is where our exhaust is going to go out. And we can see that on the engine, we'll take a look at it in a second, where the exhaust is going out to the pipe. Now on the other side, we have the impeller housing. We can tell it's aluminium. And there's our shaft again, and it looks like it's in good shape. Aluminium shaft, so the spanning shaft's going to come in here. The air from the cooler is here, and then this is going into the intake manifold, or into the engine, to supply the cylinders with pressurized. So, well, we got one more thing here I can show you. So here is where the oil comes in to cool the bearings, and that's the flow that I said that comes from the oil pump and feeds to cool the bearings. You can see on the other side, it's a large outlet, and that through gravity is going to flow back into the engine. So that's essentially the turbocharger and how it works. We'll take one more look at the engine turbocharger. Now we have an understanding of it. So we can see our turbocharger here, the exhaust going out to the stack, the exhaust manifold is here, the turbine, and then the impeller is going to spin the air from we don't have an intercooler here, a radiator that's going to bring the air in, and that's going to go back over here to the intake manifold and allow charged air.